Imagine you are starving, not hungry. Starving. You have not eaten in 3 days, and in front of you, there is meat. But it has been sitting in the sun for a week. It smells like death itself. It is covered in flies. And you have to make a decision. Do you eat it? Or do you walk away? For you in the modern world, the answer feels obvious. You walk away. Because you know what happens if you eat rotten meat. Food poisoning, fever, vomiting. In serious cases, organ failure. In the worst cases, death. So the rule is simple. Rotten meat is dangerous. Rotten meat can kill you. And yet, every single day all over this planet, animals eat exactly that. A lion eating a carcass that has been baking in the African sun for 2 days. A vulture burying its face into a rotting zebra. A hyena swallowing bones and putrid flesh whole, and none of them get sick. None of them curl up in pain. None of them die. They finish their meal, lick their lips, and walk away completely fine. So here is the question that should be driving you insane right now. How? How is this possible? Because it is not luck. It is not coincidence. There is a real biological answer hidden inside this question. And that answer is stranger than you think. Because here is the twist. Scientists discovered something in 2015 that completely changed the way they look at this problem. When researchers at North Carolina State University, led by biologist Rob Dunn, measured and compared the stomach acid levels of hundreds of different animals, they found something that stopped them cold. They expected to find that vultures and hyenas had far more powerful stomach acid than humans. They were right about that. But they did not expect what else they found. They found that humans, classified as omnivores, have stomach acid almost as powerful as a dedicated scavenger. Our stomach acid sits at a pH of around 1.5. A vulture sits at 1.0. That gap is almost nothing, which raises a question nobody had ever thought to ask. Why do humans have stomach acid this strong? We do not eat rotten carcasses. We are not vultures. So why are we built like them? Stay until the end of this video, because the answer will change everything you think you know about where you came from, and what you still carry inside your body today. First, let us understand what is actually happening when meat goes rotten. When an animal dies, bacteria immediately start working. These are not normal, harmless bacteria. These are some of the most dangerous microbes on the planet. Salmonella, cholera, listeria, clostridium, anthrax. They multiply fast. Within 24 hours of an animal dying, the bacterial load on exposed meat reaches levels that are genuinely dangerous to most creatures. A Harvard University study that examined early human scavenging confirmed just how hostile this environment is. These pathogens do not play around. Salmonella alone kills over 1 million people every year, and that is with modern medicine available. Clostridium is the bacterium responsible for botulism and gangrene. The idea that you could simply eat flesh crawling with these pathogens and be fine seems impossible. And yet, for certain animals, it is not just possible, it is routine. So how? The first answer is one you have probably heard before: stomach acid. But most people do not truly understand what stomach acid actually does or just how extreme it can get. Picture the inside of your stomach as a war zone. Every time food enters, your stomach floods with hydrochloric acid. In humans, this acid sits at a pH of around 1.5. For context, a pH of 7 is neutral, pure water. Battery acid sits at around a pH of 0.5. Human stomach acid is nearly as corrosive as that. Now imagine the stomach of a bearded vulture. Its gastric acid sits at almost exactly pH 1.0. Scientists have measured it. At that level, it is so corrosive it can fully dissolve bone, not just meat. Bone. A 2023 study published in scientific literature confirmed that the bearded vulture's stomach can completely disintegrate bone material within 24 hours. It produces something close to pure hydrochloric acid inside its digestive system. Bacteria that land in that environment do not just die. They are chemically obliterated. Cell walls dissolve. DNA breaks apart. the pathogen ceases to exist as a functioning organism within minutes. Salmonella, anthrax, cholera, all of it, gone. But here is what makes this genuinely fascinating. The stomach acid is only the first layer, and what comes after is even stranger. Once the vulture's stomach acid has destroyed the majority of pathogens, the few bacteria that somehow survive this chemical nightmare enter the intestines. And they meet something waiting for them: the gut microbiome. In 2014, a team of researchers published a study in the journal Nature Communications looking specifically at the bacteria inside vulture guts. What they found was bizarre. A vulture's beak is covered in hundreds of different bacterial species. The outside of its face, pressed into rotting flesh every single day, is teeming with microbial life. But the inside of its gut, the gut contained almost nothing. Two species of bacteria dominated almost completely. Just two. Out of hundreds of possible candidates, the vulture's gut had essentially locked down to the most ruthlessly effective organisms available. And here is the part that breaks your brain. Those two dominant bacteria species were Clostridia and Fusobacteria. You might recognize those names. In humans, Clostridia causes botulism and gangrene. In the vulture's gut, they are the immune system. These bacteria, which would destroy a human body, live peacefully inside the vulture and function as defense contractors. They crowd out and outcompete any foreign pathogen that survived the acid bath. They effectively guard the gut from anything else taking hold. So the vulture is not just protected by acid. It has evolved a gut full of biological weapons pointed outward. Let that sink in for a moment, but that's only half the story. Because there is something else going on, something scientists have only recently started to appreciate: speed. When you eat a meal, food moves through your digestive system at a certain pace. For humans, that process can take anywhere from 24 to 72 hours. That is a long time for bacteria to be sitting inside you, multiplying, looking for a weak point. Many carnivores have dramatically shorter transit times. This means that dangerous bacteria have less time inside the body before being expelled. Less time to multiply. Less time to colonize. Less time to cause damage. Some scavengers move food through their system so fast that pathogens barely have time to establish a foothold. The whole system works in layers. First, acid destroys most of the pathogens before anything else even begins. Then, specialized gut bacteria eliminate the survivors. Then, the digestive system moves fast enough to limit exposure time. It is not one superpower, it is three working in concert. Now here is where it gets personal, where it stops being a story about vultures and becomes a story about you. Remember that 2015 study by Rob Dunn at North Carolina State University. The one that found human stomach acid is nearly as powerful as a scavenger's. The researchers were confused at first. We are omnivores. We eat plants, cooked food, cultivated grain. We should have stomach acid more like a generalist animal, not a dedicated scavenger. But when they looked at the data again, the answer clicked into place. We used to be scavengers, not metaphorically, literally. For millions of years, before fire, before hunting, before tools good enough to make a clean kill, our ancestors ate what they could find. And a lot of what they found was dead. Research published in 2025 through the National Research Center on Human Evolution in Spain laid this out clearly. Early humans were, in significant part, carrion eaters. They were not the mighty hunters that old textbooks celebrated. They were opportunists. They would travel enormous distances on foot to locate carcasses. They would use primitive stone tools to smash bones and extract the fat-rich marrow inside. They would eat meat that was already beginning to decay. And paleoanthropologist Jessica Thompson of Yale University noted something important. Before fire was mastered, before cooking was possible, our ancestors were already eating rotten meat and surviving it. How? Because of the stomach acid we still carry. Our bodies evolved over millions of years to handle exactly this. The same acidic gut that makes vultures immune to rotting flesh. We have a version of it. Slightly less extreme, but the same fundamental biology. And then something changed. We discovered fire, and cooking made everything safer. the risk dropped dramatically, and over tens of thousands of years of cooked food and agriculture, our reliance on that powerful acid became less critical. But the acid never went away. You still carry it. Right now, inside your body, you have a stomach nearly as corrosive as a vulture's. An evolutionary weapon built for eating decaying flesh in a world without refrigerators or grocery stores. You just never need to use it for that anymore. But here's the part that nobody tells you. That acid is also why you get heartburn. It is why acid reflux is one of the most common medical conditions on the planet. The same corrosive system that let your ancestors eat rotten zebra is now eating away at your esophagus when you lie down after a big meal. You are overbuilt for the modern world. Your stomach acid is a weapon designed for a battlefield that no longer exists. And this matters even beyond heartburn. The 2015 Dunn study raised something that researchers are still investigating today. Modern medicine regularly suppresses stomach acid. Antacids, proton pump inhibitors, acid-blocking medications taken by hundreds of millions of people every year. These treatments change the environment of your gut. And when the acid drops, the filter changes. The bacteria that make it through to your intestines change. Your gut microbiome shifts. And what that shift means for long-term health is a question scientists are still unraveling. We evolved to have a highly acidic stomach for a reason. Disrupting it may have consequences we do not fully understand yet. So here is what this all comes down to. You look at a vulture eating a rotting carcass and you feel disgust. But biologically, you and that vulture are not as different as you think. You share the same acid. You share the evolutionary story that produced it. Your ancient ancestors did what that vulture does. They had no choice. And the evidence of those millions of years of survival is still inside you. Ticking away, dissolving your lunch, keeping you alive. The vulture did not get a superpower. It just never stopped using the one your body still remembers.